My name is Ryan Colker. I'm a Vice President at the National Institute of Building Sciences. I'm going to present today on driving to outcomes and some of the things that are going on within the industry relative to outcome and performance-based approaches. This course is available for AIA credit, so here are a couple of the introductory slides that basically say that. I'm not going to go through those, but you can certainly look in the packet or the app for all the details on those. Before I jump in, I really wanted to give folks a sense of who the National Institute of Building Sciences is, what we're thinking about, and why we're here, and why outcomes is really on our radar. The Institute was actually established by the U.S. Congress back in 1974 to really bring the public and private sector together to improve the built environment. So we do that through a variety of different mechanisms, four particular ones mentioned here, but really looking at technical criteria, guidance, and other tools that would be useful to advance health, safety, and welfare within the built environment, and bringing the best knowledge and information to the industry at large. We do that through a variety of different mechanisms. We have councils and committees on basically anything and everything you could possibly imagine related to buildings, everything from disaster and hazard mitigation issues, building information modeling, finance, insurance, and real estate. We also have a Commissioning Industry Leaders Council, which ACG participates on, and many of the other organizations within the commissioning space to really start to really drive owners to recognize the value that commissioning provides and try to provide a broad base of education to the building industry on the things that you guys do and what they provide. So let me dive in. It's probably no shock to you that we've got problems. Our building industry has lots of problems. So I'm going to go through some of those and then some of the solutions that we're actually looking for to really address a lot of those problems. The thing probably most on folks' minds is actually the industry workforce. We're certainly hearing a lot about the construction workforce itself, the availability of skilled labor, but it's not just confined to the construction workforce itself, but looking across all the various different disciplines within the building industry. One particularly concerning area is actually in code enforcement. So we did a study in 2014 for the International Code Council, really looking at the code official workforce, where they are today and where they'll be in the future. And we actually found that in the next 15 years, 80% of the existing code official workforce will retire. Currently today, over half the workforce is age 55 or older. And so, what does that mean for our capacity to enforce codes to ensure that our buildings are delivering what they're supposed to be delivering? Another key problem is actually the process itself. We have a very linear process that actually does not meet the needs of delivering high-performance buildings. And we'll talk a little bit about what that leads to. And you guys are probably familiar with some of the challenges that such a linear approach where information is just constantly handed over really leads to how buildings are ultimately operated. I really like to call it a kind of a mind the gap type of scenario where we have this disconnect between the design and construction side and the operations side. And really through that gap, we lose incredible amounts of information, incredible amounts of cost that's associated with replicating that information. And really it drives performance issues through operations. And so thinking about how do we kind of fill that gap or bridge that gap is certainly one of the areas that the Institute is really focused on. And certainly, you guys are a key aspect of bridging that gap. We also have a responsibilities gap. Architects, engineers, even code officials and contractors are content to work up front in a project and essentially walk away once things are done, while the owner, operator, and the community itself are actually burdened with the long-term applicability of that building and what it leaves for the operations team and the community to really deal with what the design and contractor community has given them. That also leads to some challenges around feedback loops within the design and construction industry to really recognize what has worked on particular projects, what has not worked, and how do we improve the overall design and construction process. Which brings us actually to building performance. I'm going to focus a lot on energy, but some of these areas are applicable to other areas of performance as well. This is not a new problem. This study actually came out when LEED first came out and really looked at the disconnect between the design intent for high performance buildings under LEED and the actual performance of those buildings. And you can see that given even a strong focus on delivering high performance buildings actually resulted in buildings that perform less than the baseline minimum code. And so how do we actually work to start to bridge that gap to really achieve the energy performance that we're really looking for? So we've focused a lot on design components, but that's really not what's going to drive us and really get us to where we want to be, whether that's a zero energy building or just a high performing building. We really need to think about operating characteristics and tenant behavior, which really ultimately contribute to how that building is actually going to perform over its life cycle. So one of the strategies that we've long looked to since the 70s to really improve building performance is energy codes. And I know it's kind of hard to see here, but we've actually made significant improvements within the code itself. The challenge is that once you get those buildings into operations, your actual results may vary. And so, if we're really looking at addressing energy performance, we really need to figure out what's going to drive actual measured performance. So digging a little bit deeper into energy codes, some of the challenges that we see today is that energy codes are a component by component approach. So we don't really have the opportunity to take advantage of systematic, system-level efficiencies, the synergistic effects across various different components. We're also seeing some limits to components themselves, whether they're technologically or economically feasible to squeeze incrementally efficient aspects out of individual components. We really need to think more broadly. Energy codes also miss a lot of the energy saving strategies that we could incorporate into building projects. So it doesn't do a very good job of capturing building orientation, for instance. And it certainly doesn't cover a lot of the operational characteristics that ultimately drive energy performance. The development process itself is actually fraught with material interests, competing on my product is better than your product, and so my product should be in the code and yours shouldn't. It's also based on a perfect world where installation and operation is executed perfectly. And it really doesn't necessarily lead to the most cost-effective strategy. It's actually just a combination of different strategies that may or may not be the most cost-effective approach. Additionally, within many code departments, energy codes are seen as a second-tier priority. It's not really perceived as a health, safety, or welfare issue within the department. I already mentioned some of the challenges relative to the limited availability of resources, particularly with personnel, but also monetary resources and technical resources as well. And generally, the overall compliance within the energy code is thought to be low, although we don't necessarily have a lot of data around that. I mentioned the challenge with strictly a design-focused type of approach, where at the end of the day, if we really want to achieve something around energy performance, we need to focus on the actual measured results rather than this kind of designed intent to meet some sort of requirement. And probably the biggest challenge with codes themselves is they actually end at the certificate of occupancy. But if you think about energy use in particular, operations drive a lot of that energy use, and occurs beyond the certificate of occupancy. And policymakers don't really understand this disconnect. They think I have an energy code, therefore my buildings are efficient, and I can meet whatever goals I set around energy policy. So I already covered kind of many of these things, but really looking at how do we address this challenge, thinking about a wider range of energy loads, incorporating things like plug loads, which we see as an increasing percentage of the overall energy use within a building. I mentioned the challenges of codes not effectively addressing operational issues. And then, if we're really going to be driving city or state or national policy around energy use, we can't just focus on new construction or major renovations to really get there. So how do we address all of these different challenges? One, I guess, kind of final problem is the problem of complexity. My coworkers like to call this the spaghetti diagram, but it's really an attempt to look at all the various different things we care about relative to buildings and how they interrelate. And I think there's also probably a parallel diagram on all the various different actors and disciplines involved in the industry as well, with various different levels of interconnection and responsibilities and roles. So now let's talk about some of the solutions and what we're thinking about to drive the industry forward. We really look at our work as moving high-performance buildings forward. And so high-performance buildings is really looking at the integration and optimization across the entire life cycle of a building, all the various different attributes that we care about. So certainly sustainability, safety, security, operations, functionality, productivity, accessibility, if there are particular historic preservation issues, functionality, and really looking across all of those different attributes across the entire life cycle of a building. So what's really going to start to drive us to achieving those outcome-based or policy-focused goals? And it's really a multi-pronged strategy, certainly looking at policies and criteria at a state and local level, looking at codes themselves, our own internal aspects within the industry, so looking at various different contracting mechanisms and procurement processes, regulatory aspects, and certainly incentives as well. So I'm going to touch on a few of these particular areas in a couple minutes. So why life cycle performance? I'm hopeful that I've already kind of outlined some of the reasons why a focus across the building life cycle is important, but certainly a design-focused strategy will only get us so far. We have an existing building stock out there that we really need to understand and get a handle on energy use across that stock. Have a more holistic approach that really looks across the most effective opportunities and not just the ones that folks have identified in a prescriptive manner. I mentioned the role of cities moving forward. I'll talk about that in a second. But also the significant impact that the U.S. building stock has on energy use and greenhouse gas emissions, representing 7% of the total energy consumption across the globe, and then certainly the associated greenhouse gas emissions equaling Russia's and Canada's combined greenhouse gas emissions. So we certainly have a huge responsibility, but also a huge opportunity to address these challenges. I mentioned cities. Cities are certainly taking the lead on a variety of different initiatives to drive energy performance moving forward. Some of that is to fill the vacuum that's created by the lack of federal policy in this area, but also, they're the implementers of on-the-ground activities within their local community. So you have a whole host of different strategies popping up, 2030 districts, eco-districts, 80 by 50 strategies to reduce their greenhouse gas emissions, climate mayors, city energy project, all of these working within many communities to really bring the industry together and address challenges within the building space. One of the early strategies that many cities have adopted, and states as well, are benchmarking and transparency policies. Really identifying how their buildings are performing within their jurisdictions, and really driving, at this point, a market-based approach to recognizing where buildings should be. Hopefully, interested tenants or future purchasers of buildings will really look to the results of these benchmarking and disclosure policies to make decisions on where they want to locate, what buildings they want to purchase, and hopefully drive some increased focus on energy performance. So that's certainly a beneficial aspect that helps move the conversation forward, but certainly it's not enough. We need to think about other strategies that are really going to drive moving forward on improved building performance. So this is actually a tool that we'll be coming out with later this year, looking at all of those various different strategies that cities could deploy to advance building performance. So looking at all the various different triggers, policies, incentive programs, enforcement strategies that really could move things forward. So let's talk about outcomes and what really that means within the building industry. I'll talk a minute about how that actually works, but really the idea is to get to actual measured performance of buildings and away from design intent to meet some goal. So outcomes really provide a comprehensive strategy and a collaborative approach, building off of many of the things that are already going on within the industry, whether that's building information modeling, more collaborative design and construction processes around integrated project delivery, contracts, and certainly commissioning is a key piece of that as well. We're also seeing an increased focus on performance within communities, within particular owners, and I'll give you some examples of what that looks like in a few minutes. And then just kind of this general policy debate and decision-making going on within particular actors within the industry with an increased focus on performance. So one of the first strategies that we looked at to drive outcomes is really looking at the code itself and providing an alternative compliance path to really get outcomes a focus of the code. And really the idea is to provide flexibility to the design team, assure that we're actually meeting desired goals in an actual and measured way, and really reporting those results in a way that really effectively drives policy. So I mentioned some of the challenges with the current energy code landscape. So how does outcomes really fit in addressing a lot of those needs? Certainly it brings a wider focus to the design, construction, and operations continuum. It's tied to actual measured results. It limits the burdens on code departments, and I'll talk a minute about what that actually means, but that's particularly relevant as we see some of the challenges that code departments are currently facing. It incentivizes a smooth handover process, and it moves beyond the current prescriptive approach to more outcome-based compliance approach, and certainly looking at opportunities to advance metering and sub-metering as well. So most of you are probably familiar with the current energy code landscape, and actually most codes kind of fall within these two different strategies. So you have the prescriptive strategy and the performance strategy. So prescriptive codes basically provide minimum characteristics for individual components, very easy to enforce, very slow to incorporate new technology. It depends on increasing the efficiencies of individual components, which I already mentioned is becoming increasingly more difficult. You don't get any rewards for efficiency improvements and design decisions that advance efficiency, and you have no assurance that you're actually achieving measurable results. On the performance code side, you're basically taking the results of the prescriptive approach and providing a little bit more flexibility for the design team, certainly a little more challenging for code officials to enforce. It does provide some technological neutrality, which is great, primarily based on energy models, but again, you have no actual measured verification of performance. So outcome-based codes really look at establishing a target energy use level with measurement and verification requirements and reporting to assure that that performance level is actually being met. It will include all energy uses within the building. It provides incredible flexibility for the design team. It assures those actual results, and it can be utilized to recognize the diversity of building types, including existing buildings and historic buildings as well, which sometimes have a particular challenge in renovation and meeting code requirements. So we've actually started to see outcome-based codes pop up in a variety of different jurisdictions. Seattle has a target performance path, which is available. The 2015 International Green Construction Code actually includes an outcome-based path as a compliance option. The 2015 IGCC is actually being utilized within Washington, D.C. As part of their new Appendix Z, which will be an outcome-based process. The Rhode Island Stretch Code as well is part of that. We're working with ASHRAE 189.1 to incorporate an outcome-based path in a future version of that standard. We did propose a appendix to the International Energy Conservation Code, and we recently transitioned that appendix language into guidance that cities could look to adopt. And so we released this in October, that if cities really want to provide an outcome-based approach, this is a mechanism for them to be able to do that, to try it in a way that provides a standard approach and really can help to move the initiative around outcome-based processes forward. So let me kind of walk through what those code provisions look like. It's actually relatively simple and short strategy for moving forward. Basically, you would set an energy target, usually provided in a table by building type and climate zone. And you could base those targets on a variety of different mechanisms, whether that's CBEX, Commercial Building Energy Consumption Survey, and all the various tools that come off of that, whether that's Energy Star, or those sorts of things, or if you have a benchmarking and disclosure requirement and have a good handle on what the building stock is within your jurisdiction, you could set your energy targets based off of that as well. Once you have the targets, the design team would actually go through the process of doing their design and really demonstrating to the code department that the design actually has the potential to meet that target. And you could do that through a variety of different mechanisms. Certainly energy modeling would be one way to do that. You could also have a pre-approved prescriptive approach. This would be particularly effective for small buildings, buildings that would be replicable. So if McDonald's, say, wanted to come up with an outcome-based strategy and have a kind of pre-approved model, they could certainly go that approach to identify that their design has the capability to meet that target. At that point, the code inspection would be based off of the parameters within that model or that pre-approved plan. And then once complete, the jurisdiction would issue a temporary certificate of occupancy or a new permit for post-occupancy valuation permit or verification permit. At that point, that would trigger for a building owner to begin collecting data on their energy use. Primarily utility bills would be that mechanism. And over a 12-month period, they need to demonstrate that they've actually met that target. And so 12 months within usually a 2 or 3 year span, so certainly giving some opportunity for startup and for figuring out any glitches, and then reporting that to the jurisdiction. At that point, either the certificate of occupancy would be issued or the post-occupancy verification permit would be closed, and then business as usual. Or if necessary, some sort of enforcement action could be undertaken. So what does that mean for potential in the commissioning space? Certainly, the bridge between design and construction and operations is one of those key areas that the outcome-based processes particularly rely on, and where you are, particularly tuned into. It really recognizes the importance of operations and maintenance training and ensuring those processes and procedures are in place to actually be able to meet those energy targets. Certainly the verification of the capability to meet those targets for the owner may be an area where commissioning professionals also could be engaged. So how are cities actually going to think about establishing outcome-based pathways? So certainly providing an initial target, thinking about the various different strategies that are going to drive those targets moving forward. What are the policies, incentives, regulatory approaches, workforce-related issues that are really going to move that forward. And then certainly looking at continual improvement to assure that the process is effective, the goals and the targets are reasonable, and folks are actually making progress on achieving the desired energy performance. So I mentioned this overall approach to increasing focus on building performance. And one organization that's really starting to drive this concept forward is the U.S. General Services Administration. So P100 is their main design criteria document, and so they've moved to a very performance-focused approach for new federal buildings. They've established four performance levels. So you have a baseline level and 3 increasing levels of performance, incorporating those criteria that they desire to meet those particular performance levels, and then actually having the measurement and verification criteria and the standards that those are based off of immediately following that. So up front, you know what the performance requirements are, and you know what the standards that will be used to actually verify that compliance. And it's actually not just on the energy side. They've looked at a variety of different building systems and strategies that they particularly are interested in. This one, for instance, is particularly focused on the location and the site for the facility as well, but it crosses mechanical, electrical, and other building systems. So we've actually taken that approach and transitioned it into something that the private sector could use as well. Certainly within the private sector, the baseline is different than what federal agencies are required to do. So we went with a code basis for the baseline, again, increasing levels of performance and the measurement and verification requirements that actually fit behind that. In addition, we've been looking at kind of addressing some of the broad issues within the industry as well, particularly around productivity. And so we've talked a little bit about some of the things that we've identified that can really help drive industry productivity forward. So certainly the collaboration piece, utilization of tools and technologies like building information modeling, which I'll talk about in a minute. Certainly an enhanced focus on life cycle, looking at the workforce, and the utilization of off-site construction as well. So ultimately, the idea is to get to a more collaborative process where everyone is engaged from the very beginning, thinking about how to provide the best possible product or building, and not necessarily kind of the pushing risk to whoever else you can push it to. And we're starting to see globally an increased focus on life cycle-based performance. UK, for instance, has this concept called soft landings, where you actually have a 3 to 5 year period where basically everybody on the design and construction team is still on the hook to really look at the project itself, lessons learned, and improve the project at that point as well. Certainly building information modeling and the process of transitioning design and construction data through to operations and computerized maintenance management systems is a key part of that, utilizing a tool called COBE, and really providing what they've called this golden thread. So thinking about why we actually built the building in the first place. And that really drives the project forward. So in addition to codes, we're actually thinking about kind of performance-based procurement processes as well, where an owner can specify energy performance requirements right up front. And so certainly that brings the planning process, the engagement of all the various different stakeholders earlier on in the process, and makes that more cost-effective actually in the long run. Because as you move further and further down the design timeline, it becomes increasingly more costly to adjust. And so if you think about all of these various different strategies up front, you actually end up with a better building. I mentioned some of the approaches and the interest in zero energy buildings, whether that's at a state or local level, places like California certainly driving their codes and their existing building stock to zero energy buildings. We're also seeing owners increase their interest in zero energy buildings. Again, to get back to what a zero energy building means, it's actually actual measured results over a year time frame, that you're actually generating as much energy on site as you're using over that entire year. So again, looking at actual measured performance results. In addition, looking at different strategies that end up at the same result, but really provide the most cost-effective approach to achieving zero energy. So thinking about campuses, communities, and portfolios as well. Again, based off of overall actual measured energy, but thinking more broadly than actually a building level project. So if you have a hospital, which is likely not to meet zero energy buildings requirements today, but a warehouse next door, if you can figure out how to match those two projects, you could probably get a pretty significant way towards a zero energy building. So thinking more holistically across various different strategies. And we've actually seen the number of zero energy buildings increasing significantly. So in 2012, we saw about, 60 zero energy or close to zero energy buildings. Today we're approaching 500. So we're certainly seeing an expansion of the interest in achieving zero energy buildings, and it's all over the country. So we see projects from California to the southeast, northeast, and basically almost everywhere across the country, and certainly that interest in achieving zero energy buildings is growing. I mentioned building information modeling as a significant tool to really help drive collaboration and more holistic processes forward. And so really bringing BIM to use across the entire life cycle of a project. And not just for design and construction criteria or operations criteria, but providing a centralized hub for a variety of different information that a building project needs across its entire life cycle. So thinking about energy modeling or procurement or even regulatory approaches, making sure that we have that centralized source of authoritative information about that project and using that data across the entire life cycle of a project rather than looking at inputting new data for different purposes or different uses. So one of the things that we've done to really help to drive interest and capturing the overall value that building information modeling provides is actually developing a national BIM guide for owners. So owners can start to ask their design team for building information, from the building information model, and really provide that strategy for transitioning that information from design and construction through operations and capturing the entire life cycle of that process. Since the release of this guide, we're actually going to be transitioning it into an ASHRAE standard. I believe it's standard 241, which is actually in the development process right now. So I mentioned this real need to look across data and information across the entire life cycle of a project. And so we really need to think about our current data management systems. Right now, we're basically looking at the scenario on the right where data is locked into a proprietary system, which you can only use that data for the particular way that system was set up to be used. And so really thinking about the utility of data across the entire life cycle of a project, we need a new approach. So thinking about a data service model where you could actually aggregate all the various different data from a project in one source, and then building apps on top of that to pull that data into various different programs depending on what the various different users' needs are. And so that really means folks are working from a centralized source of information, using that data, adding to that data as necessary, as they're approved to do, and so rethinking that entire landscape of what data within the building industry really looks like. One of the areas that we've also been looking at, I mentioned we have a Council on Finance, Insurance, and Real Estate, is actually driving energy performance upgrades within small commercial buildings, which is an incredibly difficult group of buildings to get a handle on, but they represent over 90% of the actual buildings themselves are less than 50,000 square feet. And they make up over half of the overall square footage of the U.S. building stock. So we cannot ignore small buildings. And just looking across the entire building stock, we certainly have opportunities to advance energy performance, save money, and create jobs, and really benefit our communities, our building owners. But it's really about how do we unlock the strategies and the incentives that are really going to drive us towards achieving those goals. This slide is from a little bit older survey, but I actually have the 2017 results here. This is done almost annually by Johnson Controls, looking across all of their various different customers. What are the barriers for pursuing energy efficiency within projects? And so from 2017, over a third of respondents said that there was an insufficient ROI for their particular projects. 22% said they lacked the technical expertise to evaluate whether energy efficiency strategies will actually achieve what they're intended to achieve. 21% said they had uncertainty in actually achieving savings and recognizing those savings. And 21% said a lack of funding in and of itself was one of their barriers to achieving energy efficiency and investing in those types of projects. So one of the ideas that we came up with, particularly for the small commercial building projects, was really this contractor-driven model, where the contractor would be the source for financing, information, and strategies to be able to advance energy performance within those small buildings. I think that certainly calls for a need for some sort of verification, and so I think certainly commissioning providers could be the source of that verification as well. So let's get back to kind of where we all started. The high-performance building workforce, assuring that we have the workforce in place for the future, both engaging pre-career professionals who are interested in pursuing careers within the building industry, and then the folks that we already have, and assuring that they're prepared to deliver the high-performance buildings that we're really looking for. So one of the strategies that we've actually deployed is using the very exciting developments and tools and technologies within the industry to actually have high school students operate a virtual base on Mars using a computerized maintenance management system, virtual reality walkthroughs, and scenario planning, and those sorts of things. So using tools like virtual reality, augmented reality, and BIM to really show that the industry is progressing into a technology-based profession and not one that's still reliant on pencil, paper, hammers, and nails, but really an exciting profession to be in. We've developed a Building Sciences Career Center to provide students with information on a variety of different careers within the building industry, including interviews with practitioners and linkages to specific disciplinary organizations that they can attach to. So I mentioned our Mars City Facility Ops Challenge STEM education program as a tool that we're using. to engage students, but we've actually identified some lessons learned through that project as well that really could be applied to the broader building industry. So I mentioned we're having students operate a virtual base on Mars using computerized maintenance management systems based off of a building information model. So thinking about how do we create that virtual sandbox of operating a virtual base before a shovel even hits the ground. So thinking about if we have 80 to 90% of the building information already available once design is complete, how do we use that information to develop scenarios where facility managers and operations teams can actually think through various different strategies of operating that building moving forward into the future? So on day one, they're very familiar with the project and don't necessarily need to go through the process of identifying, how that facility is actually functioning. One of the key areas that we've been looking at relative to assuring that we have a prepared workforce is in the certifications realm. So how do we understand who's qualified to do particular projects, who has the skills necessary, whether that's through a certification pathway or a certificate pathway? And so one of those mechanisms is actually through the Better Buildings Workforce Guidelines based off of ISO standard 17024 and ANSI accreditation as well. And then getting those certificates and those certifications actually into procurement and specification documents. So one way we've done that is through the Commercial Workforce Credentialing Council, which is actually the strategy that developed the Better Buildings Workforce Guidelines, that both ACG and EMA now have programs that fit those qualifications, but really identifying a common baseline of job task analysis and skills required for various different energy careers, whether that's an energy auditor, energy manager, commissioning professional, or an operations professional, and then going to the various different credentialing bodies to assure that their programs actually meet those requirements, and then getting the Better Buildings Workforce basically seal of approval from the Department of Energy, which really streamlines that opportunity for procurement and specifications as well. So you've seen this graph before. So really looking at how do we move forward on life cycle focused policies. I'm not going to go too far into this, but one of the strategies that we've looked at is a toolkit and a framework for cities. So really focusing on setting your overall policy goals and drilling those down into what are the building specific goals that folks can meet, and then moving across policies, actions, resources, and tools that the city really needs to provide to be able to effectively achieve those results. So I'm not going to go through this, but you can certainly look at the PowerPoint presentation. And as I mentioned, this will actually be available online for folks to go through later this year. But really continuing to drill down into various different strategies, being able to track what's going on, what's in the planning process, what's already done, and maybe some of the future areas that cities can begin to look at. Finally, I'm going to wrap up with a couple of examples of folks that are really taking this outcome-based or this performance-based concept to heart. One of them is the misnamed, I guess, GSA Federal Center South, which is located in Seattle. They actually included in their design contract a performance requirement that 0.5% of the design fee would actually be tied to energy performance within a year of occupancy. And so I am pleased to report that the design team did actually achieve the energy targets, but certainly it identifies the opportunity to move towards more performance-based approaches. Another project, actually in California, is a state courthouse in Long Beach, which actually pursued a public-private partnership, or which probably is, for the building industry, is probably better named a design, build, finance, operate, maintain contract structure, where everything is defined up front as far as performance strategies, and the team actually decides what is the best strategy for delivering those performance requirements. So whether they're design-based solutions, operations-based solutions, it really puts everyone on the same page to really identify what is that most cost-effective strategy. So I think it's actually a 30-year contract with a variety of different organizations from the design side, from the operations side, that really came together to pull that project to fruition. And so, tying those performance requirements to actually fees, if the building does not meet those performance requirements, really drives the ability to achieve those performance levels. So, one thing in particular, they require secure elevators for the courthouses, and so anytime there's a non-functioning elevator for more than 2 hours, it costs the team $5,000. So it really identifies what are the performance priorities and allows everyone to figure out what the best possible strategy is to address those. And then finally, University of Chicago has a new dormitory, and they actually set up a procurement based off of energy performance. So working with existing campus buildings, looking at Energy Star criteria, they identified 85 EUI as the kind of Energy Star cutoff. They set a target for 65 kBTUs per square foot per year, and then they put it out for competition with that as the basis for their selection criteria, and they actually got 4 designs back with an EUI less than 55. And so, using that procurement model, the owner was actually able to set up the performance requirements up front and demand those of the design team moving forward. So finally, I wanted to leave you with a few resources if you are particularly interested in additional information on outcome-based pathways, on performance-based procurement, and some of the other things that are going on, particularly relative to driving to more outcome-based pathways, achieving actual measured energy results, and thinking more holistically about how we move forward as a building industry to deliver buildings that meet the demands of cities, states, communities, owners, occupants, and other folks that really demand performance from our buildings. So with that, I'm happy to answer any questions and appreciate everyone sticking around. Yes?
I have a couple of things. You looked at standard 100 as a measure, as a way to verify performance, because it's set up to do exactly what you're talking about.
Yeah, so we certainly looked at Standard 100 as part of that process. Certainly the mechanism for setting the target requirements, a lot of the reporting mechanisms. So it definitely parallels some of the activities going on with 100 as part of a similar type of approach.
I'm also beginning to wonder whether EUI is the metric we ought to be using for a whole lot of reasons.
I totally agree, but I'm not sure who said it, but EUI is the I can't think of the quote, but EUI is the best mechanism that we have currently today, but we do need to think about other strategies that take into productivity of the building itself. And so thinking about whether that's a kBTU per square foot per year per occupant or per widget or per whatever, I think we need to find a more holistic.
Exactly, because how do you compare a fast food restaurant that cooks on site versus one that doesn't, as an example?
Yeah, and I think that's a broader industry challenge that we need to figure out. I think, what is that productivity metric that we really need to get to? Is it per person per year? Is it, in an office building, that may be the only mechanism you have to capture that. But if it's a fast food restaurant, is it, hamburgers per kBTU or, whatever that mechanism is. But that is a broader issue that we need to define.
I'm doing that in industrial plants, but at the moment, we don't even have a standard measure at the square foot of a building. If you look at it, CBEX and Energy Star and GSA have 3 different definitions. And GSA is using all 3 and coming up with their targets.
And then you have the BOMA ones and the IFMA ones.
And on.
So there is an effort to kind of streamline a lot of those measurement requirements. RICS, Royal Institution of Chartered Surveyors, is actually trying to define a global metric for measuring square footage. And I believe the BOMA standard is starting to align closely with the RICS international effort. But that's a big issue as well. Yep.
So when you get into the carbon disclosure project, and you know, there's a scope 1, a scope 2, a scope 3 of what your carbon footprint is. The scope 3 includes, you know, travel, vendors, you know, their emissions, you know, for delivering products. So it kind of encompasses everything that's happening. Do you see that might be a way to, kind of taking the same concept of EUI, do you think that might be a way to start capturing the entire processing footprint and EUI for a facility, regardless of what they're doing?
Potentially. I mean, it is an area where folks are continuing to look at. There's even an effort to move beyond zero energy buildings to zero carbon buildings, which certainly gets to the operations piece. There's also efforts to start to look at embodied carbon within buildings. So what are the building products that we're actually using to construct with, and what is their carbon impact? So, you know, we're starting to see that shift, but I don't think we've necessarily even gotten a handle on the energy piece yet. And so how do we take that next leap to greenhouse gas emissions? So, you know, that's certainly an area that, you know, folks are looking at, but I think, so we'll see where that heads, but it's definitely a potential opportunity as well.
I don't mean to hog the floor, but you brought up net zero. Well, an issue I have with net zero is it leads toward a low-rise approach on a large site, and it doesn't work very well in downtown Manhattan or downtown Los Angeles, and that's where the building square footage is.
Yeah, so that's actually why we've started to look at zero energy campuses, communities, or portfolios. So you don't get that when you need to build 2-story buildings on, you know, sites in the suburbs so we can capture the solar. We need to think more holistically about what is the most cost-effective strategy. And if you could start to trade off renewable energy and energy performance, you know, across a portfolio, for instance, or a community, then you can get to that most cost-effective approach.
Exactly, because transportation is another issue. If you have a big sprawling campus, now you've got transportation costs you don't have in a high-rise building.
Yeah, and to add another wrinkle to that, you know, folks are thinking about what impact EV charging, electrical vehicles have on building energy use. Can you use that as an energy storage mechanism? There are a whole host of different kind of intersection points to a bunch of different things that are going on within the industry, which makes it even more challenging. All the way in the back.
Just a question on the GSA, Federal Sentinel South, or some of those other performance-based projects that you mentioned. Are the contractual documents and the RFPs available? I mean, a lot of times the GSA makes that stuff public. I mean, we've got clients out there asking for how to implement a performance-based approach, and getting some legal documentation would be super helpful.
Yeah, so certainly the accelerated performance, which is the University of Chicago, that information is available. The website is there. They're actually using, I didn't mention it, but the NREL Research Support Facility, which is one of the first large-scale zero-energy buildings, used a procurement process that was based off of performance. And so the accelerated performance program actually took that model and is developing it into things that owners could pick up. So they certainly have that information available. I did provide the specific contract language about what that requirement is within the GSA contract. I'm not sure if the larger contract is available, but we have a case study on this building, actually on the whole building design guide. So if you just go to wbdg.org and go to, it's the tab all the way on the right. If you click down there, it says case studies. You can find this project, and so you can find the various different stakeholders and reach out to them. And if that's no help, you can certainly reach out to me, and I can try and connect you with those folks as well. But yeah, I think one of the key aspects of moving this forward is actually having those types of resources available to folks to move the ball.
We have 5 more minutes if you have any question. No question? Okay, give him a
Great.
round of applause. Thank you.